Hey guys, dealing with x and y intercepts for a parabola today. We're going to start by looking at how to determine how many x-intercepts there are without graphing. We're going to have to do a little bit of a visualization. That's the word I was looking for here. And so here's how we're going to set this up. First thing we need to do when we look at a parabola is we need to determine the vertex. And we know that the vertex for any given parabola is PQ. Watch that we make sure we take the opposite there. So -4, -2. Does it open up or down? Well, this being a positive opens up. And so here's what we want to do. We want to picture this vertex, which would be in which quadrant? 1, 2, 3, so bottom left. So you can picture -4, -2, visualize that. And if it opens up, will it cross the x-axis? First of all, not at all. One x-intercept means that its vertex is on the x-axis. And then, of course, if it will cross it twice, then it has 2. So we know if it's in the third quadrant, opens up, it will cross the x-axis. And so then we will have 2 x-intercepts. And those are our pictures up there just to indicate what we're looking for. So next one, this would be like having a +0. So our vertex, 9 and 0, opens down because of that. So if you picture 9 and 0, of course, that would be on the x-axis. Opening down means we have 1 x-intercept. And again, PQ, so 5 and 8, negative a value, so opens down. So 5, 8 will be in the first quadrant, so just give yourself a couple of seconds to picture that. 5 and 8 opening down means it will cross the x-axis twice. And last for this one, vertex of 2 and 5 opening up because this is positive. So first quadrant opening up means that it will not cross the x-axis at all, and so we have none. And this part down here is your assignment. So going to be moving over here, and this goes back a little bit to Foundations in Pre-Calculus 10 where you had to calculate them, but that was for a linear. So this is for quadratic. The y-intercept is quite easy. X-intercepts can be a little bit more challenging, and we're going to end up going back to radicals again. So I put the steps here on the side for you. To calculate the y-intercept, we substitute 0 in place of x, because that's how we know we're going to figure out where it crosses the y-axis, is when we have an x value of 0. So y equals 5 times 0 minus 7 squared. Always follow order of operations, so we would take -7, square it, 49 times 5. And don't be concerned when you see something like that, unless I ask you to graph it, of course, because that wouldn't work out too well. And I always ask for ordered pairs for that. Next, substituting 0. Now we want the x-intercepts in most cases, so we're going to put 0 in place of y, and this so we'll divide both sides by 5. And then we'll take the square root of both sides. And of course, normally we would take the positive and the negative root, but since we can't have a -0, so we just have 1 here. And in this case, we only have 1 x-intercept. I'm just going to box those up. There we go. Okay, moving over here, same deal. So it doesn't matter which one you start with first. Most students, I think, do the y-intercept first because that one's kind of the easier one. So what do we have here? -1 times -1 is 1. So 1/3 minus 3. And we want, when we subtract fractions, we need a common denominator. So what divided by 3 gives us 3? Well, that'll be 9. 1 minus 9 is -8. So 0, -8. There we go. And now 0 in place of, it's going to test our fraction skills here, minus 1 squared. So we want to isolate x minus 1 squared, so we'll add 3 to both sides. And in order to get rid of this, we would normally divide both sides by a third, and there's absolutely nothing wrong with that, but if you'd prefer not to divide fractions, what we do in grade 9 when we're dealing with this is we always multiply both sides by the common denominator. And now when we get here, we take the square root of both sides. This is where we want to remember the plus and minus 3, x minus 1. And I always suggest to students to bring that over, because you have to do 2 calculations. This one has 2 x-intercepts, right? So 1 plus 3 is 4, and 1 minus 3 is negative 2. And so we have 4 and 0, and negative 2 and 0. All right. Moving on to this one, y-intercept. So 3 squared is 9 times 2 is 18. 18 minus 24 is negative 6. You can, of course, just type that into your calculator. And x-intercepts. And remember, we're going to isolate the x plus 3 squared. So I'm going to add 24 to both sides. Divide both sides by 2. Take the square root of both sides, plus and minus. Now remember, if we can simplify that radical, we need to do that. So we're going to break that down into root 4 times root 3. And the square root of 4 is 2, so positive plus and minus 2 root 3. And we need to isolate x, so these are our 2 x-intercepts, which of course means that obviously they're not rational numbers, they're irrational numbers. So if you're graphing this, I highly recommend taking a calculator and just typing it in to make sure. So when I take this one into my calculator, I get 0.46. And you can picture where that is on the x-axis, right? Where your parabola should cross the x-axis, and this one is negative 0.646. So not necessary to put them into decimal form, but just kind of gives you an idea of if those are reasonable. And the last example here, we'll just do the y first. 1 squared is 1 times 2 is 2 plus 6 is 8. Going to isolate x plus 1 squared, subtract negative 6. That's a bad x. Taking the square root of both sides. Now once you type that into your calculator, it should tell you there's an error, because we cannot take the square root of a negative number. And so this is where sometimes we look at it and we think, well, what the heck happened? Did we make a mistake? Well, let's take a look at this. And this is why that very first thing that we did, where we determined the number of intercepts, this is going to show us something. Our vertex is negative 1, 6. So negative 1, 6 is in the second quadrant. Picture that. And it opens up or down? Opens up, so it won't have any x-intercepts, and this is the mathematical way of determining that there will be no x-intercepts. So no x-intercepts. And there you have it.